rolling there. We're live there. And here. And I just need to do one more thing and then we can get going. Okay. Supposed to have where I can. Supposed to have calibrate. Where's the calibrate? Time I come in here or something wrong. I guess we'll just do the best we can. All right. The first two things that I want to bring up, four things, is the first four definitions in your 1.2 material. And that is population, sample, data, and statistics. And there they are. So, go ahead and make a reference to this page. Make a reference to the yellow box as well as those four definitions. And I said four, and I know there's five up there, but I really don't care about census because that's not necessary for you. I knew it wasn't going to be calibrated. So write those down in your notes if you don't have them, or put them down somewhere. What room is this? All right, data. If I was to go through the classroom and I was to say, I want to find out how many blondes, brunettes, and redheads are in here, that would be obtaining data. One, so far I only see one redhead. 2, 3, I see 3 of you. Diane, you don't count. So I see 3 redheads, see a few blondes, maybe 5 or 6 blondes, and then the rest of you are those lovely brunettes. Just some people are gifted with being brunette. That's all there is to it. And brown eyes. But anyway, data. So that would be 15, 5, and 3. That's my data. What about statistics? Well, taking those statistics and finding out, well, if I have a classroom, I can pretty much guarantee you that I'm only going to have a few redheads, and that's usually true. I'm taking those statistics and I'm using them. I'm calculating what the mean, median, and mode is. And I can pretty much tell you that having more than 3 redheads, 10% in a classroom is going to be odd. Even though some of you brunettes have red in your hair. You just don't know it. All right. Population. Population is the big kahuna. In other words, population is the big guy that you're taking statistics from. A good example, United States would be a population, South Carolina would be a sample. A sample is always a subgroup of the population. If I did a population of Tri-County technical students, that would be Pendleton, Easley, and Anderson, and any other campuses we have, and use Anderson campus as a sample. Okay. Now, the whole purpose of probability and statistics is to be able to take a sample and predict with a certain accuracy the same thing for the population. For instance, if I decided that I wanted to see how many people were in the Marlboro Club at Tri-County Tech, and I said, well, I'll take a poll and see how many people were in the Marlboro Club at Anderson campus. And I find out that 28% of the people at Anderson campus are in the Marlboro Club. Well, after using some probability and statistics, I can say with a 93 or 95 or 97 or 98% confidence level that the population of Marlboro Club at Tri-County Tech is going to be around 23% or 28%. Now, why is that good if I can do that with a small sample? Well, if I can do it with a small sample, then Michelin can do it with a small sample. And Bosch can do it with a small sample. And IBM and all these other big companies can do it with a small sample. What does a small sample mean to a big company? Small money. In other words, you don't put as much money into a sample as you do a population. Now, where does it come good in the business aspect of it? Business aspect is you can use in marketing, you can use a small sample of people to predict what the population is going to be. So, if I was a hair company marketing person, then I would like to know how many people are redhead, and how many people are brunette, and how many people are blonde. Okay? So those are some ideas, those are some examples of these 4 definitions. Next thing, I want to get this down a little bit. Hold on just a minute. Get rid of this, hide that, there. And I want to make this down a little bit. There we go. Just hold on, I'll get to the page as needed. Page 11. Make sure you can do those 4 things. Now I'm going to put some problems up on the board here in just a minute, and you're going to try them, and then we're going to go over them. Now I'm not doing it to insult your intelligence. I'm doing it to make sure we knock some of the cobwebs loose. So write those 4 things down. You don't have to write them word for word. You can just write the examples. You don't have to write the words down. You can just write the 4 examples and make sure you understand what they are. And then I'll throw some problems on the board and we'll work them. So that way I want to make sure everybody knows what's going on. as far as percentages go. Now, I'm going to put a nice little do-jigger on the board, and we're going to do some problems. Still trying to find the do-jigger. She says I need to put the pen over the flame on the board. Maybe I need to right click. Maybe I'll do that. Right. No, it don't work. Now, did I do anything to make it quit working? What did I do to make my pen quit working? Is a percent over 100. Some of you might recognize that.
I'll figure out what's wrong with this stupid board.
Is of equals percent over 100. I need you to write those down. And of course, some of y'all probably recognize that. It's one of those things that you just don't, that you need to know and don't need to forget. Now, the types of questions that you will be needing them on are the following. 16 is what percent of 227? That's one question. 23% of 437 is what number? And the last one, what number, no, 16% of what, 16 is what percent of what, blah, 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 23% of, and then 16 is 32% of what number? Now there are three questions right there that can be done with is a percent over 100. I like to call these sentence questions because, on your standardized test, some of you nursing people, you will see these over and over and over and over on standardized tests, entry tests, to get into the program and all that stuff. You will see these, so do them. 16% of what number is 227, or 16 is what percent of 227? 23% of 437 is what number? And 16 is 32% of what number? What time is class over? Y'all need to make sure we get in class at 2:10. I have to pick up my son this week. 2:30, and I don't want DSS standing out there, because I'm there late, and I don't want that. Campbell, did everything work out right? Mm-hmm. Blank pages, I've been told, try all three of the, try Google, try Firefox, and try Internet Explorer. Even though it doesn't say, I don't think they have their grasp on what's wrong, but somebody told me the other day that they were getting a white screen, and they went to Internet Explorer and it worked fine. So try that.
I'll try that. But like when I did the whole My Life Bridge, when I click on that, it's just a blank screen. So I can't type it in.
I think it has, you know what I think it has to do? I think it has to do with Blackboard.
Yeah.
Because they're forcing y'all to go through Blackboard because nobody uses Blackboard, so they're forcing y'all to use it so they can say that people are using it. But nobody uses it because it breaks down all the time.
And I have not had one single problem going in through MyLabs Plus. And MyLabs Plus, I think you can go through and ask for a password. I believe you can do this. I don't know if you can register or what. You might want to call them and ask them, MyLabs Plus people with support, and see if you just can't go through the daggum website. And I bet you won't have any problems.
Because this, like the access code thing gives you like a website, like, no, it's just giving you the website.
Yeah. I would try it through the other website and see if you can get a password for it. I bet you $1 it'll work every time. Yes, sir.
Yeah, I had the same problem, but it just like showed an app when the thing was running.
Yeah.
Try it in. What have you tried so far? Firefox and Google Chrome.
Yeah, I tried Google Chrome and Internet Explorer.
Okay, try Firefox. And then what have you tried?
Google.
All right, try Firefox and then try Internet Explorer.
Okay.
Try all three. And if those don't work, I would call customer service and say, look, if you can give me another password, can I go through the MyLabs Plus, tctc.mylabsplus.com, and see what they say? Okay? That thing just beat. What the heck is it beeping for? Yeah, I know. It acts like it's working, but it's not. It's a conspiracy is what it is. It's all Bush's fault. I'm not starting it over. I'm sorry, because I started over, it's going to wipe out my video that I've already done. Okay, so is of percent. 16 is, where does that go? That goes over the 16. So what I'm going to do is I'm going to dangle copy this, dangle copy paste, dangle copy, get down here and dangle paste. Okay, so that guy turns to 16, and then percent turns to what?
It's not on the board.
X, and then of turns to what? 227, and then you're good to go. And then cross multiply, you're going to get 227x is equal to 1600. And somebody take out your calculator and tell me what that turns out to be. X is equal to 7.048, which is 7.05. And that's your answer. 16 is 7% of 227. And you feel good about yourself. Question on that one? I can't win. No matter what I do, this computer's just fighting me hand and foot. All right, I take all this and do it down here. So in this case, it would be 23 is going to be over 100 and of 437, so it should be X over 437 is equal to 23 over what? Now, I know it doesn't look like yours, but I'm trying to, I'm trying to do the best I can. And that's 100x is equal to 437 times 23. Somebody tell me what that is. 10,051, is that right? Now, please don't use a calculator for the next step because then people will laugh at you. X is equal to 100 point what? So 23% of 437 is 100.51. And the last one. IT person wants me to call her, so while y'all doing that, I'm gonna call her. I'll get a sip of this. she says they're finding problems with the cables. And that's why the Promethean will be working and then it'll just stop working. So, okay, I'm good with that. I can handle that. They're going to bring new cables over. So, we'll see what happens. 16 goes where? 16 over what? X is equal to 32 over 100. And then that comes out to be 32x is equal to 1600. And somebody tell me what x is. How many? 50. So 16 is 32% of 50. Now those three type questions, you may think, oh, that was easy. Yeah, but how easy was it before you saw them? You know, did you have to remember? And the only thing you need to remember is of percent over 100. Capiche? All right. You have successfully signed out of your e-text. I didn't sign out of anything. You see what I'm having to work with up here? I mean, you've signed out. You've signed out. Document expired. Resend. Tonight is the El Herrero's night. I can feel it already. I just can't get my son drunk. DSS will say something. He's only 8. Alright, let me look down at the bottom. Nothing there. Alright, and that's 1.1, I guess, or 1.2. Let me get to 1.3. And the 1.3 starts, yeah. 1.3, write that down. Parameter and statistic. Parameter and statistic. I wonder if I wiggle the table, I wonder if that'll work. Take something to tap on it. What is a parameter versus a statistic? Well, remember, parameter starts with a P, so it goes with population that starts with a P. And statistic goes with sample, and they both start with what? S. What is a parameter? Well, this is only for, there's no mathematical value here. All right? Parameter, for mean, you have what you call mu. M-E-W. That's what mu looks like. Some people draw it this way. Oops. No, they don't draw it that way. Some people draw it that way. It's a weird looking M. And it stands for mu. M-E-W. Now, if you're in a president's report to the president, if you're in an annual luncheon, if you're in a marketing presentation, if you're in a conference or a workshop and a PowerPoint presentation comes up and it says mu is equal to 57.5. Mu is the population mean. Write that down. Whenever you see mu in any setting, that means the population mean. Mu is the population mean. Mu is the population mean. Now, what's the other thing that's important? The other thing that's important is omega, or sigma, I'm sorry. sigma. And sigma is the population standard deviation. Excuse me. Parameters are always Greek letters. Write that down. They're always Greek letters. 10 years from now, y'all may be sitting in a board meeting or director's meeting or a workshop, and you may be giving a PowerPoint presentation, and you have a question, and you see that mu is equal to 2.7, and the standard deviation is equal to 45. Well, you might stand up and say, I have a question. It looks like to me your population mean and your population standard deviation need to be switched. And it could be a misprint or whatever. Okay, what does that person know about you after you just said that sentence? She's just making me out look bad. No. What is she saying to herself as the presenter? That you know a little bit about what? Statistics, yeah. Thank you. I appreciate that whisper. That you know a little bit about probability and statistics because you knew that they were Greek letters, so you knew that it was population mean and population what? Standard deviation, Hubert. Thank you, class. Appreciate the interaction. A statistic is the same thing, except statistics do not use Greek letters. Guess what they use? Regular old letters. I can't stop yawning today. I don't know why. Chasing all them wild women, that's what it is. I'll wear you down. Guys, remember that. So what's the difference? Well, in this case, X bar and S. X bar is standard deviation of the what? Well, we've already talked about population. What else is there? The sample. Can't get nothing past y'all. Cricket's chirping in here. S is, oh shit. X bar is the standard deviation. How about the average? Or the sample mean. S is the standard deviation. Of the sample. Let me ask you questions. Are the mathematical formulas for either of these, are they different or the same? The mathematical formulas for the population mean and the population standard deviation are what to the mean of the sample? What mean and standard deviation? Are the formulas different? Yes or no?
Yes,
That's what I
they
heard.
are.
What?
Yes, they are.
Are they the same or different?
They're different.
You're wrong. Get out. You're a failure. They are the same. Then what's the difference between parameters and statistics? Parameter shows you that you're dealing with the what? Statistic tells you that you're dealing with the what? That's all it tells you. So you don't look ignorant in meetings, basically. You know, if you see mu up there, don't say, well, that's a sample mean, isn't it? Then your boss will know that you're what? Stupid and need to be out of the office. They're going to fire you right there. And you're going to become a loser, and you're going to have to put smokestacks on your truck just so you can feel good about yourself. All right. Or jack it up 15 foot tall. Have you ever noticed that people with smokestacks on their truck and they jack up, and I'm not talking about 3 or 6 inch lift kit, that's okay, but 16 feet in the air, you ever notice when they get out, they're either short, bald headed, we won't talk about the other one. And sunglasses inside. You ever seen somebody wear sunglasses inside? Or when it's raining outside? Oh my gosh, I'll never forget. I took my son and my daughter to the Christmas parade one year in Anderson. And it was like 30 degrees outside, and it was like almost dark because it was so cloudy. Y'all may remember it 2 or 3 years ago. It was cold, and it was cloudy. It wasn't nothing like this. It was gray. You know how that gray is? And there was all these men out there with those sunglasses on, and I couldn't figure out why they had sunglasses on. But just about every one of them didn't have any hair on their head. So I didn't know if it had something to do with the hair on the head or the reflection of the sun or the clouds on their head or what. But next time you go to a Christmas parade and it's cloudy, see how many men are wearing their sunglasses. I didn't see a woman with a pair of sunglasses on. Girls, you ever see a guy wearing sunglasses on inside, run as fast as you can. Run. Smokestacks, run. Oh, $10,000 worth of TV equipment in a $1,000 car, run. I'm telling you, I got 25 indicators, caveman indicators. It will tell you, run. Now, I haven't got one for the guys because there's only 3 indicators that you dating a crazy woman. I'm not going to get into those in this class. Okay, because there's too many women in here. Too much estrogen for this testosterone. I'm sorry. I got a lot of testosterone, but not enough for this class. All right, Kevin Bacon. Why are they doing Kevin Bacon? Why they got a picture of him? Oh, 6 degrees of separation. How many of you have heard of that game? Huh? You have? What are they? Well, you give me an actor or an actress, and in 6 tries, I can get it to Kevin Bacon. Now, if you don't know Kevin Bacon, you're lying because he's been in just about every movie there is. Right now, he's doing a TV show. What's the TV show called? It's a TV show. I don't know. He's a killer or something in one of the miniseries or something. But his famous, one of his most famous films is what? Footloose in the 80s, the original Footloose. Can anybody tell me of a film that he was in before that? He was in Animal House. He was the guy, thank you, sir, but I'll have another. He was getting spanked. Y'all don't even know what Animal House is. So 1 or 2 of you may be. He was pledging with the fraternity, and they had to get spanked 100 times or whatever with a board, and he was in that. He was in a lot of movies. He's one of those actors that are in a lot of movies. So name I'm not very good at it, but name a actress or actor. That's not rhetorical. Nicole Kidman. Nicole Kidman played in Eyes Wide Shut, which was a bizarre soft porn movie about a woman, but anyway, with Tom Cruise. Tom Cruise played in A Few Good Men with Kevin Bacon. That's 3. I did Nicole Kidman and Tom Cruise. That's 2. Try another. Brad Pitt did a movie with George Clooney. George Clooney did a movie with Julia Roberts, I believe, didn't he? Huh?
Yeah.
Julia Roberts was in Flatliners with Kevin Bacon. What movie was George Clooney in?
The Ocean 11.
Yeah, Ocean's 11. Yeah, one of those movies I've never watched. There's some movies I don't watch. That's one of them. One more. You know, y'all were not dead the first time we met, okay? What happened? Did somebody tell y'all something about me or what? I brush and I floss and I take baths, okay? So you can talk to me. I don't have to look at that one. I don't know who that is. I know the Notebook, but I can't remember the face. You have to do somebody else. I don't know her. Who's that? Give me a movie.
Jackie Chan Rush
Oh no, forget it. Jackie Chan, I don't know who that is. I mean, I know who that is, but I don't watch those movies.
Okay, George C. Scott.
Okay, wait a minute. Jamie Foxx. Jamie Foxx did. Oh gosh, Jamie Foxx did too many movies. Okay, you can do this. Jamie Foxx did a movie called Jarhead. Jarhead's about Marines. Then you can go back to the Marine movie, which is A Few Good Men, which is Kevin Bacon. You can do it like that too. George C. Scott. I don't know too many movies. I know George C. Scott did the Bible. He also did Patton, and he did Hindenburg. Those are the 3 movies that I can remember, but I'm trying to. Hindenburg's too old to relate to Kevin Bacon. It would have to be Patton, and you would have to say Patton was in the Army, and he was a general, and I don't know how you could do George Patton. I mean, George C. Scott. I got to remember some of the movies he was in.
Wasn't he Jackie Gleason's manager in The Hustler? Is that right?
Yes, he was.
Yeah.
Okay, you probably could go there, yeah. But that was Paul Newman.
Yeah.
Paul Newman
Yeah, that was-
did The Color of Money with Tom Cruise. Tom Cruise did Few Good Men with Kevin Bacon. Thank you. That was good. I forgot about The Hustler. So what do you have to know in order to play the 6 degrees of separation? You have to know the subject area. I, for one, like movies. I like movies more than I like sports. I'm not a caveman. I don't watch sports. What's it called? Yeah, I don't watch it. I don't even know what channel it is. I don't sit there and wonder when LeBron James went to the bathroom or, what he ate for breakfast like some of those guys do. Have you ever seen these guys on ESPN? I mean, the commentators. I wonder if they have conversations about anything else. I mean, have you ever sat and listened to them? It's all they talk about. I guess I'm not one-dimensional. But anyway, you got to know your subject area. And I like movies. So I can hold my own, but I'm not a professional. Why is this important? Well, it says social psychologists, historians, political scientists, and communication specialists are interested in the small world problem. Given any 2 people in the world, how many intermediate links are necessary to connect the 2 original people? In the 1950s and 1960s, Social psychologist Stanley Milgram conducted an experiment in which subjects tried to contact other target people by mailing an information folder to an acquaintance who they thought would be closer to the target. Among 160 such chains that were initiated, only 44% was completed, so the failure rate was 73%. Among the successes, the number of intermediate acquaintances varied from 2 to 10, with a mean of what? And that's why you've got the 6 degrees of separation. Have you ever heard of Hollywood Golf? Any of you? Do the app on your iPhone or whatever. Hollywood Golf. Let me see if I can remember the two. I can't remember the two. Okay. Brad Pitt and Kate Blanchett, thing old Titanic. Yeah. Link them two together. Try to link those two together. Now, they have not played in a movie together. I don't think they did what?
Yeah.
What? Okay, well, that's a hole in one. You just got a hole in one. Because in golf, if you could relate them in one shot, you got a hole in one. But that's not what they wanted. They were showing how to come from showing you. That's not what they were showing. Leave. All right. Brad Pitt played in Fight Club with Edward Norton. Edward Norton played in a movie which I don't know because I don't know even who he is, but he played in another movie with Mark Wahlberg. Of course, you know Mark Wahlberg. One of my favorite movies with Mark Wahlberg is The Shooter. I love that movie. I could watch it like 5,000 times. Mark Wahlberg played in with DiCaprio. Yeah, he played in the movie. He was the only one that survived. It was like not The Untouchables, but it was called The Departed. The Departed. Was it The Departed? Y'all are stupid. Okay, he played in The Departed with Leonardo DiCaprio, and Leonardo DiCaprio played with Kate Winslet in several movies. One was Titanic, and the other one was she played a very small part in The Aviator.
Kate Winslet.
Yeah. Very small part. But you can do it with Titanic also. And you could also do it with Revolutionary Road. You ever heard of that one? Have you ever? Oh gosh, that's depressing. If you're a young married couple, do not watch that movie. It is depressing. It was set in the 50s. He works, he gets a good job. She wants to move to Paris and live life free. They conflict. They start hating each other, and she ends up dying. It's not a good movie. It's about like, you ever seen Denzel Washington's movie, The Flight? You expect for it to be a good movie. Have you seen it? Yeah. It sucked. It sucked. Because they had Denzel Washington being a drunk, and then the Marlboro Club. When I'm talking about Marlboro Club, he ate cigarettes. He didn't just, oh gosh, it was terrible. I hated that movie. That's the only Denzel Washington movie I hate. Don't watch it. It's not worth the money. You'll leave and you'll want to go out and buy smokestacks for your truck. All right. So that is the 6 degrees of separation. So now you can go home and play it with your friends. 6 degrees, and you can do it with anybody. You could do it with Rock Hudson. You could do it with that. You could do it with any type of things. But what they're saying is that normally you can link people together. They said the maximum was 10 times, and then the least of 4 times, or whatever. The mean was 6, and that's where the 6 separation game came from. Okay, I'll shut up. At least you know that today, which is meaningless, but that's okay. Quantitative and quantitative. Qualitative and quantitative. What is quantitative? Well, do y'all remember the words from your parents, or the words from a TV show, or words from somebody you know? I would like quality, not quantity. You ever heard that before? What kind of setting would you hear that in? Snobby setting, yeah. Country club, we want quality, not quantity. What about if you, let's say that you invented a new product and everybody went crazy over that product and you started making them in mass production. What would you want to keep in your product that you invented? Quality. You would not want to, you don't want to start putting out stuff that's melted together because this machine did this and melted two of them together. And, okay? Quality, not quantity. So quality has to do with the aspects of the product, has to do with the aspects of the person, has to do with blue eyes versus brown eyes, or brown hair versus brown eyes, or brown hair versus blonde hair. Some of us, some of you are not blessed to have both brown hair and brown eyes, okay? There's only a few blessed people in the world that have those, right? Correct? Well, some of you may have a little bit of blessing with the brown hair and the blue eyes, but, you know, the brown hair and the brown eyes, you know, you just can't beat it. Some of y'all go, look at them. Okay, so some of you have brown eyes, some of you have blue eyes, some of you have gray eyes. Some of you have, you know, green eyes. Some of you have hazel eyes. That's qualitative data. Now, redheads, blondes, brunettes, we already talked about that. That's qualitative data. Even though I count you, the 3 redheads that are in here, the 3 that I saw, that's qualitative data. But once we get to your height and your weight, that's when it turns into what? Quantitative, because it means quantity. And quantitative data means that I'm measuring you somehow. The average the average shoe size of the class, that would be quantitative. The color of your shoes would be qualitative. Got it? That's a test question. You need to highlight that because you're going to see that. And we all feel good about ourselves. That's 17. Uh-oh, I done skipped something. There's a test question. Do not write the definition. It will confuse you. Just put discrete data on the top of the page, and about halfway through the page, put continuous. That's how much page you're going to need. Now, I'm going to have to type it on here since that blame thing quit working. So, I'm going to type, and you can listen and write, whatever. And I'll try to make it a little bit bigger. Discrete. I like to tell students to think of the word concrete. I like to tell students to think of rational numbers. Some of you are going, I don't even know what rational numbers are. Okay. Rational numbers. Are numbers that are predictable and locatable. What the heck is he talking about? Okay, here we go. 2, negative 3, 5.5, 1/2, 1/6, negative, where's the negative button? There it is. Negative 6/7, 5, negative 10, 3, negative 7. All right, why are those numbers, why are they predictable or locatable? I'll even add one more. Oh, well, I'm going to add them below it. All right, what is 2? 2 is locatable because there's nothing behind 2, is there? What's the only number you can put behind 2? Point what? 0. Same thing with negative 3. Negative 3, the only number you can put there is 0 because 3 is 3. 3 eggs, 3 toes, 3 windows, 3 TVs. There is no hat. There is no anything. It's very predictable. It's very locatable on the number line. How about 5.5? Is there anything behind that 5? Yes, what? 0. 1/2? Same thing, 0.5. Oh, well, Hubert, 1/6 ain't. Yeah, it is. 0.1 what? And what's over that last 6? And what does that mean? It repeats. What about the other one? Negative 0.6666666 again. And it's repeating. I'm not going to put a bar over it. Well, what about 5? Well, 5 is 5. 10 is 10. Negative 3. Negative 7. It doesn't matter. They're all what? Predictable or locatable? Well, what does that have to do with discrete? Well, we'll get to that in just a minute. Continuous. I like to tell students irrational numbers. Now, if Hubert gives you the definition that a rational number are numbers that are predictable and locatable, what can I tell? What can you deduce that I'm going to tell you about irrational numbers? They're what? I didn't hear you. All I heard was blah, 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 blah.
Unpredictable.
They're unpredictable. Irrationals are unpredictable. Oh well, I didn't mean to put it in capital caps. Unpredictable, unlocatable. What else? Well, there's just no. Well, I don't want to put that because that'll give away my thunder. All right, I'm going to just write 3. The square root of 2. Do it on your calculator. The square root of 7. Do it on your calculator. And pi. All right, somebody give me 10 digits of the square root of 2. 1.41, 42, 13, 562. Anything else? All right, somebody give me the square root of 7.
2.64,
All right, somebody give me pi. I can do 3.141579. What else?
1.592. No, 3.141592.
92. 9, 2, 6, 9, 4. Well, let's take pi right now. Everybody's got 10 digits. Can anybody in the world, can anybody in this room tell me what that next digit is? Without calculating it or using your calculator. Just by looking at the pattern. Can you tell me? You can't look at the pattern because what? There ain't none. There's a difference between there isn't any and there ain't none. Just like there's a difference between a whipping and a whooping. What's the difference in a whipping and a whooping? A whipping, you just got popped. A whooping, you got your ass whipped. Okay? Some of you people know what I'm talking about, especially with mamas that pick switches or fly swatters. Fly swatter, the handle of the fly swatter. Woo! Thing hurts. I'm not talking about the plastic ones. I'm talking about that wire one. Woo! Yeah, I'm deranged and crazy. I got whoopings when I was a kid. It also, a whooping also means in bar terms, you just got wiped up with the floor. Okay? Well, ain't there means no trace whatsoever. There is no pattern to those numbers at all. Now, which one of these is which? Well, this guy means all over the place, don't it? Sporadic. Okay? This one is what? What would you say these numbers are compared to these sporadic numbers? Solid. Right? So write that down for both of them. These are your solid numbers. And these are your what? Not so solid. Now I'm going to bring it home now. I know what time it is. Let's say that I ask y'all, there's about 30 of y'all in here, and I have up here, I got on this desk, right here, a box of measuring items. Tape measures, tape measures that carpenters use, tape measures that you use for field day. It comes on a roll, they like that, reel them up. I got tape measure that the old carpenters use that you unfold. I got tape measure, all different kinds of tape measures. Digital readout tape measures. Don't have anything on the, because you don't know how to read the tape measure. There's people like that. Don't raise your hand, please. Okay, so I got 30 different types of these. They're in a box. And I go tell everybody, go outside. Everybody see that sign right there beside that cement slab? Well, y'all can't see it. There's a sign down there that probably says, don't stand on the cement slab, okay? And it's about 4 foot tall. And I tell each one of you to go down there and measure that sign. How many different measurements will I get, or will y'all come back and give it the same measurement? That's not rhetorical, I'm asking. What do you think? Why? Why do you say that? Exactly. Everything. And people can't read. People can't read. They'll just say, that's 4 foot. Okay? That'll be 20% of y'all. Okay? The rest of you, some of y'all just put it on top of the concrete and measure up. But it's not in the concrete, it's in the what? It's in the ground. Some of y'all will say, I need a shovel so I can dig down and see where it actually meets. Okay? Some of y'all will just half measure it. Some of y'all will measure it meticulously. Some of you will use the digital readout, which instead of 4.1 feet, it'll say 4.158. Some of you say 4. So, what can you tell me about measuring that sign? Would that be discrete or would it be continuous? That's it. So what would be discrete? If I counted everybody in this room and I told everybody to count everybody in this room, what would you come up with?
same number, unless you can't count over 10. You would come out with the same number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Somebody else count right now. Give y'all a minute to count while I pull up the attendance. Including me. Okay, I'm waiting. 29. Anybody else? Huh? No, we're all too lazy to count. Okay. The whole point is, what is counting? Is counting discrete or continuous? Discrete, because it's solid. You can't mess it up unless you just don't know what you're doing. Okay. Now, stop.